Hello everyone, hopefully you're doing well. In this video, we're going to continue with chapter one, Introduction to Statistics. In this section, we're going to focus most of all on the types of data. If for some reasons you missed the first video covering statistical and critical thinking, I strongly advise you to go back and take a look because we're going to continue here because a major use of statistics is to collect and use sample data to make conclusions about population. We should know and understand the meaning of the term statistics, and parameter. So I would say statistics without S here. It can also include S if we refer to more than one statistics, right? But we're gonna consider only one without S here because we already covered in the previous video, section 1.1, another meaning of statistics with S, where we define it as the science of planning studies, experiments, obtaining data, organizing, summarizing, presenting, analyzing, and interpreting those data in order to draw conclusions about the population. So we did go over that definitions before. So what we're gonna do here, most of all in these sections, we will describe a few different types of data. The type of data is one of the key factors that determine the statistical methods we use in our analysis. So let's try that. Okay. What we're gonna do first of all, we would describe the basics of different types of data. Then we'll consider big data or missing data. Uh, if, to start, it's important to review parameter and statistics without S. So parameter is a numerical measurement described being some characteristic of a population. So anytime we refer to some informations, where it would involve the population, the data about the population. For example, if you run any census for some reasons, the data collected from the entire population, we can call it parameter. But if we use a subset of that population, we call it a sample. So the data we collect from a sample, we call it statistics without S. A numerical measurement describing some characteristic of a sample, we call it statistics. As we said, we may have more than one statistics. We may have more than one data collected from a sample. So in this case, we will call it statistics. We would add S. Very important to review this. All right, but let's say some data I briefly described a little bit data that are quantitative and qualitative in the previous video, but here that's our goal. That's our main goal to review and provide all details and descriptions of quantitative and qualitative data. So quantitative, we call it qualitative data or we call it categorical data. Some data are numbers representing counts or measurements, like, if we talk about weight, height of an adult, weight of an adult, age, number of siblings you may have, the amount of money you have in a bank account, number of yellow M&Ms in a bag. So those represent numbers. Those are numbers, right? Representing counts or measurements. Whereas others are attributes, such as hair color. What is your hair color? What is your eye color? What is your country of birth? What is the middle name of your mom? So these are all, what is your major? They are all attributes that are not counts or measurements. The term quantitative data and categorical data distinguish these two types of data. Right? So we're gonna go first on Quantitative data, or we call it a numerical data, consists of numbers representing counts or measurements, like the weight of a supermodel, the age of a weight, as we said. We can say height, right? We can say age, right? Those are a few examples, you can use as quantitative data. But for categorical data or qualitative data, you can call it also qualitative data, or attributes, consist of names or labels, not numericals, not numbers that represent counts or measurements, right? So we don't need that. That the gender, what is your gender, male, female, or a transgender, if you want to, how you want to identify yourself, in terms of gender, but you cannot choose a number. So shirt numbers on professional athletes, even though those numbers on the back of the jerseys, they are numbers, but they are not really numbers, right? They are mostly attributes or labels. And also your social security number is not quantitative data, all right? So it's mostly categorical or qualitative data. If you see your telephone number, even though it's a number, it's not technically a number, it's a label, so attributes. But numbers are the ones you can, there are some gaps you can count. If I count 2, 4, 6, 8, the next one will be 10, 12, 14, 16, etc. If I count by 1, 1, 2, 3, 4, 5, 6, the next one would be 7, etc. But if I say, what is your major? The fact that someone is in engineering and someone else is in nursing, or someone else is in biology, or someone else is in administrative science, doesn't mean like you can organize them in order, which one comes first and second. So that's why we said those are qualitative data. Qualitative data. How do we work with those data? So working with quantitative data, we can work with them, of course. Uh, that's include quantitative data. We can also work with qualitative data. So quantitative data, I think before we get there, I'm gonna do these examples before we go with this type of data. Sorry, I need to move, change um, the order. Now, in these examples, all we need to do is to identify uh, uh, in the following data, which one is quantitative data, which one is qualitative data? Nationality of passengers on an airplane. So we're talking about nationalities. Nationalities are not numbers. If we see nationalities of people, in an airplane, so we know it's categorical. So categorical data. All right, or qualitative data. It's not the number of passengers. If we're talking about number of passengers in an airplane, that would be quantitative. But because passengers are numbers, one, two, three, four, five, number of passengers. But this we talk about nationalities. Zip codes also, it's mostly a label, right? So it's categorical, but most of all, we can use quantitative data. Also, we can qualitative data. So we can take either categorical data or qualitative data. Age of dogs and at a rescue facility. Now, age letters, words, or numbers? Yes, numbers. So that's quantitative data. Type of flowers. For those of you who know flowers, you can decide what you want to do with the type of flowers. But we know at some point type of flowers can be qualitative or categorical. I'm gonna write qualitative so you remember qualitative. Okay. Names of towns where branch campuses of a college are located. Name of towns, those are words. So it's categorical, right? And distance of track events. Remember, distance are numbers because it can be in feet, in meter, in miles, in inches, distance in kilometer. So, this is quantitative data. Response times for a customer service representative. So response times can be 2 hours, 3 hours, 4 hours, 5 hours, 6, 7, 8, 9 hours, or maybe 2 minutes, 3 minutes. Again, talking about times, it's mostly quantitative because we're dealing with numbers, right? Quantitative. Colors of the M&M candies. So remember the colors can be yellow, blue, black, brown. I don't know which one you like the best in the bag for M&Ms. So we know that's qualitative or categorical. Qualitative or categorical. The weight is what? Yes, quantitative because we're dealing with numbers. And the cigarette brand? Yes, that's categorical or qualitative. So remember, we can say either qualitative or we can say categorical. So it all depends, which editions of the book you use or which book you use directly. They would use more categorical than, qualitative. But at the end of the day, they mean exactly the same thing. All right. So that's our first examples. As we said, with quantitative data, it's important to use the appropriate units of measurements. It's very important to remember if we talk about money, then that would be in dollars, pesos, euros, goods. It all depends. And some measurements are in dollars, hours, feet, or meters. We should carefully observe information given about the unit of measures because some measures like can be in thousands of dollars, or all units can be in kilograms or ounces or pounds. You need to really pay attention to that because ignoring such units of measurements can be very costly. So that's very important to pay attention to these type of informations. Now, all right. Working with data, all right. As we said, we go with two of them when we said data. Remember, we said data can be quantitative, quantitative, and categorical, or you can say qualitative, categorical, or we said qualitative. So quantitative, remember this is numerical response. Qualitative, non-numerical results, right? Now, when we deal with these two number data, another things you need to see qualitative data because we said quantitative data. We talk about age of people, or categorical data. We can talk about the gender, male or female. Categorical data, it all depends, and you can call it qualitative data as well. Now, quantitative data can be further described as distinguishing between discrete and continuous, So we have discrete, finite, discrete, and continuous. Now, these two datas, we have discrete and continuous. One is when you do finite count and when you have infinite count. So let's say for discrete, result when the data values are quantitative and the number of values is finite or countable. Like if there are indefinitely many values, the collection of values is countable. So if it is possible to count them individually, such as the number of tosses of a coin before getting a tails, it's all depends. Now, look, discrete data, there is no chance that the discrete data can be decimal. For example, any data you take, like you expect the answer to be a whole number. How many people were in the airplane? Well, 355. There is no way it can be 355.5. How many yellow M&Ms in the bag? So that's that discrete. How many How many suitcases in the airplane? Those are discrete. So we can have the number of suitcases, yellow M&M in a bag, we can take yellow M&M in a bag, in a candy bag, right? All right, so that's one of them, I mean that's discrete. But for continuous data, result from infinitely many possible quantitative values where the collection of values is not countable. So it is impossible to count the individual item because at least some of them are on continuous, some of them are in continuous scale, such as the length of distance from 0 centimeter to 12 centimeter, for example. So that's very important to see it that way. It is this way. So some examples of continuous data, the amount of oil spilled on the floor, height, weight, of some people. So height and weight. Remember, there is a possibility of getting these as decimal. So, we need to check that. Now, let's see in the examples very quick. Which of the following describe discrete data? Remember, discrete data, it's uh discrete data is the whole possibility of obtaining whole numbers. There is no way you can obtain decimal, and also it should be finite. Like the exact height of all NBA players, basketball players. So height can be decimal, 6.5, 6.7, 8 point something, 5 point something. So this is not discrete, that continuous, but the access to identify only those that discrete. The number of people surveyed in each of the Gallup polls preceding the next president, number of people. Is there any way you can obtain a number of people decimal? Is the number of people can be decimal? No, people always whole numbers. So 10 people, 20 people, never say 20.5 people. So the B, yes, B, which of the following discrete? So this is discrete then. This one is discrete because there is no possibility of obtaining a decimal, all right? The exact times that randomly selected students spent on smartphones during the preceding week, exact time. So you can spend 2 hours, 3 hours, 4 hours, but 4.5 hours is possible. 20.2 hours is possible. The fact that you have so much uh, opportunity of obtaining a decimal number, so it's continuous. Remember, discrete must stay discrete is discrete numbers are all whole numbers. They are whole numbers, not decimal. Identify whether the given value is statistics. I think that's another definitions we need to cover because remember we talked about statistics at the beginning. Statistics is about statistics without S. It's about sample parameter, it's about population. A survey, all right, we're gonna try this one. A survey of a sample consumers in the United States showed that among those who have found a wallet of purse, 89% either turn it in or locate the owner. They said a survey of a sample. So if it's a sample, then it's a statistic, right? According to the Federal Highway Administration, there are 212 million licensed drivers in the United States. Does that look like a decimal, a sample too, or the whole population? Yes, it's the whole population, so it's parameter. So that's the total of people in the United States that has a driver's license. The sinking of the Titanic on April 15, 2012, I mean 1912, is one of the most infamous disasters in history. A population of 1,503 passengers and crew died when the Titanic sank approximately 400 miles south of Newfoundland, Canada. So now they said that's the entire populations okay, that die. So they don't take a sample of it. So that should be a parameter. In a study of a sample of babies born at hospital in New York State, it was found that the average weight at birth was, remember they said a sample of babies, then it would be statistics. Thank you. I'm glad you see this and we can enjoy it because the next examples, it's about whether we're dealing with discrete data or continuous data because as we talked about it before, discrete, remember we said result in the data values that are quantitative, okay? So it's quantitative, okay? Um, it's quantitative. That's very important. Now, in a study, we're going to go with that example. So also in a study of weight gains by college students in the freshman year, in a study of weight gains by college students in the freshman year, researchers record the amounts of weight gain by randomly select students. So we're talking about weight. There is a possibility it says a decimal 2.12, 212.3. So we can say this is continuous because as we said, we're gonna go with the possibility of obtaining a decimal, all right? And while monitoring internet traffic in order to detect fraudulent activity, the researcher records the interval of time. So it can be 11.3, okay? It can be 12.5, it can be 15 something. At the same time, of course, you can obtain a whole number, but it's maybe also decimal. So again, that's continuous. The clerk of the U.S. representative record the number of representatives present at each. Is there any possibility that the number of people recorded present here can be decimal? No, cannot be decimal, so it's discrete. Your statistics professor records the number of students who passed each of per course. So statistic professor record the number of students. Can the number of students be decimal? No. If the number of students cannot be decimal, then it's discrete. In a study of service time at Amazon, the times it takes to process order are recorded. Any chance it's decimal? Yes. So it's continuous. We're going to use those examples, of course, to do more exercises in this section, okay? Because we're going to have a lot of exercises in the homework where you can use these type of information. So hopefully you enjoy and do it properly, right? So that's very important. Now, another very important topics we would cover, here is a way of classifying data to where we would use four level of measurements. We're going to use level of measurements that we call nominal, no, level of measurements ordinal, interval, and ratio, right? That's very important because we're going to define what each of them is. In terms of nominal, because we need to review all of them, the nominal level of measurements is characterized by data that consists of names, labels, or categories is only. The data cannot be arranged in any order. You're not paying attention to it, So if you want to make a list of houses for rent in the area, if you want to verify the number of flights scheduled for a very specific day at a very specific airport, because you know what, the flight numbers are just information. You cannot make sense of them. That means you cannot add or subtract the flight numbers to give you something. When you subtract one flight number from another one, it doesn't mean anything. So mathematical computations is not really important, right? So when we do for nominal, you know, when we do for nominal level of measurements, as we said, this one, you don't need to do anything harder on it, right? Example, survey response of yes, no, or undecided, those are nominal, very nominal, because nominal data lack any ordering or numerical significance. They should not be used for calculation. So we don't need to do any calculations for nominals, right? When you see numbers like 1, 2, 3, 4, sometimes assigned to different categories, but these numbers have no real computational significance or any average. Like as I said, when you see yes or no on a survey, or if you take the flight numbers, they mean nothing, right? So qualitative data only you need to use for that one. Categorize using names, labels, or qualities. No mathematical computations can be made, so that's also very important. So very important. Or we said for the ordinal data are the ordinal at the ordinal level of measurements if they can be arranged in some order but different obtained by subtraction between data values either cannot be determined or meaningful. So ordinals, like you have rank, you can put them in order. Top 10 movies or on specific platforms, right? Or you can, I mean, anything you can rank from first to last, or in order. There is order in this one. So ordinal data provide information about relative comparison, but not the magnitude of the difference, right? So ordinally, and ordinal data, like let's say for the grades, for example, the grades are A, B, C, D, F. You should never be used for calculations as an average, right? But it's important to pay attention to order. Order, like it's ranked from first to last, right? From the best to the worst. If there is rank, then it's ordinal, right? Ordinal are quantitative data or qualitative data. Data can arrange in order or rank. The difference between data entries is not meaningful. Now, the next level, because we have 4 levels: nominal, ordinal. Now, the next one is interval. That has to do with quantitative data. All right. Data can also be arranged because we said for that level of measurements, if they can arrange uh, you know, for the if they can be arranged in order, differences can be found and are meaningful. If there is a natural zero starting point where zero indicates that none of the quantity is present, for data at this level, difference and ratios are both meaningful. So remember, zero really represents a position on the scale, not an inherent zero. Zero does not imply none. So what we mean by that, if we said I have $0 in my pocket, I really don't have any money in my pocket. But if I said it is 0 degree Fahrenheit, you know that zero is different from $0 in your pocket, zero siblings you have, right? But 0 degree Fahrenheit, that means it's very cold. Doesn't mean nothing, right? Now the next one, the last one, of course, we have 4 levels of measurements. We have a nominal, ordinal, intervals. The last one is ratio. Okay, so definitions of ratio, we said can be arranged in order, for ratio. Ratio is similar to interval level. Sometimes it's very difficult to make the difference to do the difference between ratio and interval because they are very similar. Zero entry is an inherent zero, so that means really implies none. If you say it's zero, then it's zero. Ratio of two data values can be formed. So one data value can be expressed as a multiple of the other. Usually ratio, we do it with music, right? You see it in music. It's like one song is longer than another song, like by 5 seconds. Let's say your favorite artist have an album released, and some songs are only 2 minutes and 55 seconds. Other songs are 3 minutes, or it all depends. Now, we have four level of measurements, nominal, ordinal, interval, and ratio. As a summary for the level of measurements, nominal categories only, that means it's only qualitative data. Ordinal categories with some order, it must be ranked, the top 10 movies, top 10 musics, it's top 10 university in the US. When you say top 10, that means the first one is really the first one. And interval, differences, but no zero point, and ratio, differences, and a natural 0 point. Remember the zero, inherent zero, 0 degree Fahrenheit, and $0 in your pocket. There's are two different zeros. The 0 degrees Fahrenheit, that means it's very cold, but $0, it means you have no money. So it's two different zeros. All right, let's go doing some examples very quick. Determine which of the four level of measurements, nominal, ordinal, or interval, best describe the given data. We're going to review these examples very quick. The first one, in order to better plan for the incoming freshman class, a college dean ask each newly admitted student to identify the likely major: physics, business, math, psychology, engineering. There is no rank on this one. It's just you nominate them. It's like you only list them. So that should be nominal. U.S. News and World Report periodically provides its ranking of medical school, and in a recent year, they ranked for Harvard, Johns Hopkins, and New York University were 1, 2, and 3, respectively. So that's really ranked. It's in order. That's ordinal. In a college film studies course, students rate 10 documentaries using a scale of 0 to 5 stars, right? So which one you think this one should be? You rate them from 0 to 5. Yes, it's order. That's again ordinal. Oh, I give you two examples for ordinal. That's good. That's good. Um, what if we said in a criminal study, the length of prison sentence are obtained for randomly select subjects convicted of auto theft? Hmm. So which one you think this one would be? Yes, that would be ratio. As I said, length of time, if you review length of time is ratio. Interval is like, how often Patriots win the Super Bowl. So if you, how often NBC is they have won the best Grammy or for some reason. So, those are intervals. But what we want to do for this one is really ratio. A data set consists of the areas of each of the 50 states. And of each of the 50 states. So what would that be? Yeah, ratio again. Baseball statistics, Bill James records the years in which the baseball World Series is won by a team from a national. So you understand this is interval because I already talked about it. The last part, we're not gonna do any exercises, but I would leave it for you to read and understand what we mean by big data. When working with data, we might encounter some data sets that are ginormous, and we might also encounter some data sets with individual element missing. So it's mostly why, either it's too big or there are some information missing. So for us, big data, how many letters that US Post Office delivered every year. So you can refer to that. So big data refers to data sets so large and so complex that the analysis is beyond the capabilities of traditional software. So analysis of big data might require software simultaneously running in parallel in many different computers. So remember, it's not everything you can do with Excel. Excel is only something very practical, and also you can find it it's accessible very fast, but you know, some analysis would be too big. Data science involves, application of statistics, computer science, and software engineering, along with some other relevant fields, like sociology or finance, we have so many of them that would take terabytes or petabytes or exabytes to run. And our regular computer is not enough to do it. We have some big, few of them like Google. If you take Google, Google provides live traffic maps by recording and analyzing GPS data collected from smartphone people traveling in their vehicles. So it's very difficult to run these. I mean, to manage these in a regular computer. Netflix collects data on viewing records and use the data to create original programming as well as identifying which movies to require. So many of these we can do. If you even take like Walmart websites, that's not easy, right? To do. Um, as I said, we have some missing data. Missing data also, a data value is missing completely at random because missing data is, when collecting sample, it's quite common to find that some values are missing. Ignoring missing data can sometimes create misleading results. So if you make the mistakes of skipping over a few different sample values when you are manually typing them into a statistical software program, the missing values are not likely to have a serious effect on the result. However, if a survey includes many missing salary entries, um, because those with very low incomes are reluctant to reveal their salaries. Those missing low values will have the serious effect of making salaries appear higher than they really are. So we need to really make sure that it's that, a data value is missing not at random if the missing value is related to the reason that is missing, right? So very important. Correction or how to correct missing values, you can always verify that. Okay, we can do some correction or for there are different methods for dealing with missing data, delete cases on, let's say, on very common method for dealing with missing data is to delete all subjects having any missing values or input missing values. We put them back. We input missing values when we substitute values for them. There are different methods of determining the replacement values, such as using the mean of the other values or using random select values from other cases. So hopefully that's helped you to understand types of data. We said we have two types of data, qualitative data and quantitative data. Quantitative data can be either discrete or continuous. In a different video, we would come back to talk about collection of sample data. Hopefully you enjoyed this, and I'll see you in a different video. Take care.